Leetcode number 21, merge two sorted lists. So we're given the heads of two sorted linked lists, list 1 and list 2, and we want to merge the two lists into one sorted list. The list should be made by splicing together the nodes of the first two lists, and we want to return the head of the merged linked list. So imagine here in example 1, we have the list 1, 2, 4, and the other list is 1, 3, 4. The new merged sorted linked list is going to be 1, 1, 2, 3, 4, 4, because those are the elements from the first two lists spliced together and then merged to a sorted list. Let's look at another example. If we have two empty lists, so list 1 is empty and list 2 is empty, simply return an empty list. And if we have one of the lists empty and the other is not empty, we can basically just return the non-empty list. And keep this idea in mind because this will be helpful when we're solving the problem in full. So what about the constraints? Well, the constraints are that the number of nodes in both lists is in the range of 0 to 50. So either there's no nodes or there's 50 nodes or anything in between. And the values in each node is going to be between -100 and +100. And finally, both list 1 and list 2 are sorted in non-decreasing order. In simpler terms, we can just think of this as increasing, but some of the values might stay the same. Okay, so let's talk about the solution, and it's pretty simple. So what we're going to do is we're just going to maintain two pointers for each of the lists, and then what we're going to do is take the minimum between the two values that the pointers are pointing at and add that to our answer list. So if you don't know what I mean, let's run through an example really quickly. So imagine we're given the two lists, 1, 2, 4 and 1, 3, 4, 5. What we're going to do is maintain two pointers here, and we're going to take the minimum out of both of these. So if they're actually equal, what we can do is arbitrarily pick one. So let's just pick the top one. Then what we're going to do once we've picked one, we're going to move the pointer of the one that we just picked one step ahead. So we're going to move this to the 2. Then between these two pointers, what are we going to do? What we're going to do is pick the minimum. So in this case, the minimum is 1. So take the 1 and move the pointer. What about between 2 and 3? Between 2 and 3, 2 is the smallest. So we take the 2 and move the pointer ahead. What about between 3 and 4? Well, 3 is the smaller one. So we take the 3 and move the pointer ahead. Between 4 and 4, we arbitrarily pick one. In our implementation, let's just say we always pick the first one. So we're going to pick the first one, move the pointer ahead, and notice that one of our pointers is actually now in the null space. So it's pointing to a null pointer, or it's a null pointer now. And what do we do in this case? Well, remember that if one of the lists is empty, then we can just return the other list. So we're just going to take the other list that's not empty, and we're just going to return that into our list already. So now we just take that 4 and 5, we don't even need to process them individually, we just take that entire list and append it to the end of our answer list. So that's the idea here. Let's talk about the code now. When we're dealing with, linked lists, recursion might be a really good way to do this. So let's work with our base cases first. For any recursive function, we deal with a base case, and we have two base cases in this case. So the first case might be that if the first list is null. If the first list is null, then we can just return the second list. And what happens if the second list is null? You guessed it, we return the first list. Then what we need to do is think about our recursive function, or how do we transition from this current state to the next state? Well, what we can do is we can first check whether or not L1's value is less than L2. So this means that we want to pick L1's value. So what does that actually mean? What that means is that we can pretty much just say that L1.next is just going to be the merged list of both the next value and L2. And then what we can do is just return L1. So if you don't fully understand what this means, what it means that we just want to merge the rest of the list in L1, right? And L2. Similarly, we can do this for the other case where L2 is less than or equal to L1. All we need to do is say L2.next is the merged list of L1 and L2.next. Then simply return L2. So once again, if you don't know what that means, it basically just means that, okay, we're done everything before L2, right, we don't need to deal with. But from L2, from the current value and onwards, we just need to merge L1 and L2 onto it. And then this will keep happening recursively until both lists are merged and sorted. Now, this is a little unintuitive, and it takes a bit of practice to understand this. So let's look at the time and space complexity before we move on. So the time complexity is just going to be O of n plus m, because we're just going through each of the lists. And if the first list is of size n and the second is of size m, then the time complexity is just going to be O of n plus m. The space complexity is actually going to be O of n plus m as well. The reason that being is because we're creating new values each time. Okay, so what about an iterative approach? This might be a little more intuitive. Well, what I'm going to do is I'm going to first create my prehead, and this is basically just going to be my answer. You can think about my answer. Then what I'm going to do is I'm going to get a reference to that answer, and we're just going to say, okay, first process whichever one is shorter, right? We're just going to process until one of the pointers are null. So what we're going to do is simply say, okay, well, if L1 is less than or equal to L2, right, the value's there, then what we can do is we can just say, okay, prev.next, right, the head or the answer.next is equal to L2. And then, so that's pretty much just bringing L1's value and then putting it into my answer. Then L1 equals L1.next means, okay, move the pointer onwards. Similarly, for the other case, we can just say prev.next is equal to L2. And so that's pretty much bringing L2's value onto the answer and then moving it forwards by saying L2 is equal to L2.next. Then what we're going to do is we want to move our answer pointer forwards by 1. The reason we do this is because we just finished creating our answer for the current value. Now we move on to the next pointer where we can store another node. Then what we're going to do is we're just going to say, okay, well, if prev, or we can just say that prev.next, right, is whichever one is not null. So if L1 is null, return L2, and if L1 is not null, then just return L1, right? So this is basically just saying, okay, take whatever one is remaining or left over. And then simply we just need to return prehead.next. The reason for prehead.next and not just prehead, the reason for that being is because of our implementation and how we did it. We started off with a dummy node, and then we're saying, okay, the next value is going to be the answer instead of the current value. And that makes it a little easier to implement. And now let's analyze the time and space complexity. The time complexity is going to be O of n plus m, and the space complexity is actually going to be O of 1. The reason it's O of 1 is because we're not creating any new nodes. We're just reusing the ones from L1 and L2. And that's pretty much it for this Leetcode solution.